Once again, one and all. So from today onwards, we will start with our module number 3 of a subject called as the dynamics of machinery, basic concept. So today we will start with the basic concepts of mechanical vibration. So as I said earlier that module number 1 and module number 2 was based on the theory of machines. Module number 3, 4, 5 are completely based on the mechanical vibrations. So to start with the actual model, first of all, we have to understand what are the basic concepts of mechanical vibration. Okay. So we'll start with, I hope I am audible to you. If I am not audible, please message me accordingly. Okay. So we'll start with, first of all, introduction to mechanical vibration. Okay. So before I explain you the concept of mechanical vibration, first of all, you should know who is able to vibrate, or which body will vibrate, or where the vibrations will occur, or in which body, or which, or you can say the component subject will undergo the vibrations. Okay, so basically, if you can see a statement over here, right? When any elastic body, okay, basically, how does the vibration occur? So this statement is really important. When any elastic body, such as spring, shaft, or beam. So important thing is that the body should be an elastic body. The body should be a elastic in nature. Now, already you have studied the strength of material mechanics. You know what is elasticity. Okay, I will not go into the deep what is elasticity. So any elastic body, for example, spring is there, shaft is there, beam is there, it is displaced from an equilibrium position. Equilibrium position means what? Static equilibrium position. Okay, so any body is which is at a static equilibrium position, or it is under a rest condition. So if you apply, so you know that when the body is in a rest condition, unless and until you apply some force, okay, unless and until you apply some force, the body will not come into the motion, right? So this is what we have already studied. So same is the case with the mechanical vibration. An elastic body is such a spring, shaft, or beam is displaced from the equilibrium position, then and then only by the application of external forces, and then released, it commences a cyclic motion. Okay, I haven't still defined vibration. I am just started with. Okay, so what will happen? It will commence a cyclic motion. For example, I have already explained the concept of compound pendulum. So let us take an example of a simple pendulum. So let us say this is a static condition of a simple pendulum. Okay, now let us say you apply external force. Apply external force means what? You are giving a small angular displacement theta. Let us call it position number 1, 2, 1. Okay, this is position number 1. So position number 2 and position number 3. Okay, I will explain you in the detail later on. But now you can see that this pendulum has commenced a cyclic motion. That is, it is moving from 1 to 2, 1 to 2, and again 2 to 1, and again 1 to 3. And you can see that this pendulum is oscillating. Now already we have a wall clock. From our childhood, we have seen a large wall clock. So inside that, you have a pendulum which is placed inside the glass. So that pendulum is continuously oscillating. So that is also one kind of vibration. Okay. So I hope you have understand this statement. Okay. So such a cyclic motion of a body or the system due to the elastic deformation under the external force is known as vibration. So cyclic motion of a body. Now you know that if you take an example of a spring, you take an example of a beam. Okay. You take an example of a shaft. So these all are nothing but elastic bodies. Okay. So what will happen? So whenever you are applying a force, on all these elastic bodies, spring, beam, and shaft, what exactly happens is that they will undergo the elastic deformation. The system will undergo the elastic deformation because of the action of external forces, and then the cyclic motion will get commenced. For example, if I take an example of a spring, okay, what will happen? When you apply the force, let us say you are applying a force in a downward direction to the spring will start vibrating, right? So this spring will start vibrating. Means what? The spring is going some sort of elastic deformation, okay? And then it will commence a cyclic motion, and then it is called as a vibration. Okay? So this is, you can say the definition of a vibration. Okay? So all bodies possessing mass and elasticity are capable of vibration. So what is important? So this is nothing but important condition. So for body to undergo a cyclic motion, to undergo a vibration, it should have a mass and the elasticity. So spring is there, shaft is there, beam is there. So they all have a mass and they all have a elasticity. Now please message me, have you, now I will explain you one by one the example, a detailed example of how does this motion. Now already you know that there is a cyclic motion of a body due to the elastic deformation under the action of external forces. But exactly how it happens, we'll understand. Okay. So let us take an example. I will explain you two examples. One is the spring mass system, and second one is a second example. I will explain you the which one simple pendulum. So here to understand, first is the equilibrium position, and second is the extreme position. Okay, so let us understand. So first of all, exactly we'll consider a simple spring mass system. A simple spring mass system is what? There is a spring having a stiffness K. The unit of stiffness is Newton per meter. Always remember. And then having a mass, spring is defined by K, having a mass M, having a unit kg. Okay. Is it clear? I hope you understand what I'm trying to explain you. Okay. Now, basically, we have to understand the phenomenon of vibration. What we have to understand? We have to understand the phenomenon of vibration. Okay, so for that I have taken an example of a spring mass system. Okay, now basically initially the spring is at an equilibrium position. The mass is at equilibrium position, and obviously spring is also at an equilibrium position. Means what? Whole system is under the equilibrium position because still you haven't applied an external force. Okay, so this is called as the equilibrium force. Now let us say you apply an external force F in a downward direction. Okay, now you know that let us say x is the displacement. Let us say x is the displacement. Now you know that the displacement will be always in the direction of the applied force. So displacement will be in the direction of applied force x. So x dot is equal to velocity. So I am defining some terms. So x dot will be also in a downward direction, and let us say x double dot is nothing but the acceleration. So it will be also act in a downward direction because the application of force, the applied force or the external force in a downward direction. Okay. So is it clear? Now what happens when, now let us understand the concept. Let us understand the concept exactly what happens. So whenever you are applying an external force, you are applying an external force means what will happen? Can anybody tell me what will happen when you are applying external force on this mass? This system will get dispersed. This system will get disturbed. This system will get disturbed means what? Means what?
Shift from displace from equilibrium position.
What basically means what? The work is done, right? You understand what is work? The work is done by an external force. So work is done by an external force. This is very, very important statement. So whenever the external force is applied on a spring mass system, which is at an equilibrium position, the work is done by an external force. Okay, and this work done by an external force means what? It will produce a displacement. It will produce a displacement. It will produce a displacement, or you can call it as a deformation also. You can call it as a deformation also. So this work done by an external force F will produce a displacement or deformation, and obviously now whenever you are applying an external force, whenever there is a displacement, whenever there is a deformation, there is some opposing element. There is some opposing element, and this opposing element is nothing but the internal elastic forces, right? They are called as the internal elastic forces. Very, very important point. Okay, internal elastic forces, and they resist the motion or they resist the deformation. They resist the deformation. So let me complete the statement now. What I want to say. So when the spring mass system was at an equilibrium position, now you apply the external force. So when you apply the external force, the work is done by the external force, and it will produce the displacement or deformation against the internal elastic forces, which will resist the deformation. So you know that this spring is nothing but elastic body. Okay, so it will try to resist. So internal elastic forces will be developed inside the spring. Okay, and this internal elastic forces will resist the deformation or will resist the what? They will resist the
External force.
they will resist the external force means what? They will resist the deformation or they will resist the displacement. Okay. So now you know that obviously now the work is done. So this work has to be stored somewhere. Okay. Now this work done, very, very important. This work done is stored. This work done is stored in a spring, and this work done is stored in the spring in the form of energy. It will be stored in the form of energy, and that energy is called as the elastic strain energy. It is called as the elastic strain energy. You might have, I think, studied this concept in the song strain energy, right? You have also derived a formula for this. So we will directly use that formula. So elastic strain energy. This elastic strain energy, my dear students, is also called as the internal potential energy. Very, very important. Internal potential energy. Okay. Means what? The work done which is stored in the body or the spring is called as the elastic strain energy, or it is called the internal potential energy. And this formula I will explain you later on, but just to uh, help you to understand, you just remember that this formula is nothing but a 1 of k square. So how this came, we'll understand later on. So this internal potential energy or elastic strain energy can be calculated by this formula 1 of k into x square, right? Because k is nothing but the, what is k? K is nothing but the stiffness of the spring, and x is nothing but the displacement, and which is in the direction of the applied force, right? Is it clear? Now tell me, have you understand what has happened exactly here? I have applied external force. Work is done by the external force, which will resist by the interelastic forces. Now this work done is stored in the spring against the elastic forces. Okay. So this is a step number one. This is a step number one. So let me erase this now. Now exactly what happens? Okay. Now let us say that you are removing this external force. Now let us say you remove this external force. Let us say that you remove this external force. So when you will remove this external force, what will happen? What will happen? The internal elastic forces, I am writing everything because maybe sometimes I am talking and you may not get my voice clearly. Okay, so I am writing everything. So when you remove this external force, first of all you have applied. What has happened? Work is done, energy is stored. Work done is stored in the form of the internal potential energy. Now we remove the external force. So what will happen? The internal elastic forces, these internal elastic forces will try to bring body to its original position. To its original position means what? They will try to bring its body to the equilibrium position. Okay. Now in the mechanical vibration, we are always considering a frictionless motion. Very, very important. Each and every point I am talking is very, very important. Okay. Frictionless motion means what? In vibration, we are always assuming a zero friction. So in vibration, there is no friction while doing an analysis. So since there is no friction, there is a zero friction, there is a frictionless motion, and you have removed the external forces, what will happen? The interelastic forces will try to bring the body to its original position. Okay. So basically what happens? This strain energy, now tell me where is the strain energy stored? This is called as the internal potential energy. This internal potential energy, or you can call it as the elastic strain energy. Elastic strain energy. So my dear students, what happens whenever you are removing a load? Sorry, whenever you are removing a force, okay, and if the motion is frictionless, that is a zero friction, this is very, very important. What will happen? The internal elastic forces I will try to bring the body to its equilibrium position. Means what? Means what will happen? This internal potential energy, or strain energy, you called it as a strain energy, is converted into a kinetic energy, right? Is converted into kinetic energy. Have you understand what happens exactly? So now guys, you may have understand that there is a conversion of energy over here. First the work is done. First the force is applied, then the work is done. Then the work done is stored in the form of this internal potential or elastic energy. Now you remove the force. If the motion is frictionless, there is a zero friction. This internal elastic forces will try to bring the body to its equilibrium position, and the internal potential energy or the strain energy will get converted into the kinetic energy. So there is a conversion of energy. Okay, so let us understand. Now you can see this. Okay, so this is nothing but a step 2. What has happened in the step 2? The mass has moved in a downward direction. Why? Because you have applied an external force. Okay. Now basically what happens? In next step, whenever you are using a force, the mass has to come to its original position, that is the equilibrium position, but this will not happen. Why this is not happen? Because when this mass come to its equilibrium position, your complete internal potential energy, that is your completely internal potential energy, has converted into the kinetic energy. Means what? At this equilibrium position, your kinetic energy is maximum. I hope you understand this. When this mass started moving, try to understand guys, when this mass started moving back, Why it started moving back? Because you have removed the force. The kinetic energy, potential energy gets converted into the kinetic energy, and when this mass comes to this mean position, the kinetic energy becomes maximum. So remember always that kinetic energy is always maximum at the mean position or the equilibrium position, and that is why, guys, this mass will not stop at this mean position, but it will move above the mean position. Okay, and when it will move above the mean position, तो कुठपर्यंत मूव होणार आहे? Where it will stop? It will stop when your complete kinetic energy becomes zero. Okay, so let us say that this is the position where mass stops. This is the position where mass stops. At this position, your potential energy becomes a maximum, and these positions are called as the extreme positions. These positions are called as the extreme position. So basically, finally, the moral of the story is that at equilibrium position, you have understand what is happening. At extreme positions, let us say these are nothing but extreme position. So at extreme position, your potential energy is maximum. Okay, so these two are nothing but a potential, and at mean position, your kinetic energy is maximum. Okay, so because of this, vibration is nothing but a convergence of energy, and when potential energy will become zero at this extreme position, again this potential energy will start converting into the kinetic energy. Again the mass will come to the mean position. Again the mass will come to the downward direction. Again the potential energy maximum becomes maximum. Kinetic energy becomes zero. Again the mass will come to the mean position. Again the mass will come to the extreme position. So this mass will always try to oscillate between the mean position, upward position, and the downward position because of this convergence of energy. And this process is called as a cyclic motion or a oscillation or a vibration. Now I just want one question answer from your side. This process will continue up to where? When will this continuous process will stop? There is a motion of a mass from the mean position to the upward direction to the downward direction. ही पोझिशन हे कुठपर्यंत चालू राहणार आहे? Yes. Anybody? I hope you understand what is till complete energy does not dissipate. Okay, so you know that energy can neither be created nor be destroyed, it can just be dissipated. So unless and until if all the energy is dissipated through all the cycles means what? This is the cycle, na? Mass is moving from the mean position to the downward position, again to the upward position, again to the downward, again to the upward mean position. So this is an indefinite cycle. So unless and until your whole energy is dissipated, this cycle will remain continuously and the system will start vibrating. So as an engineer, you have to design, for example, if you take an example of a compressor, if you take an example of an IC engine, whatever system it is vibrating, you have to design such a way that this energy is dissipated as early as possible so that the system will come to its equilibrium position. I hope it is clear to you now. So this process is called as a mechanical vibration. Now you know that this is the external force, and see, you know that you will say that sir, how the energy entered the system? Initially there was no energy in the system. The energy entered inside the system. Because of these external forces, right? And then this energy gets stored into the potential, that is elastic strain energy. Okay, and then it gets converted into the kinetic energy, and then the cycle process was repeated indefinitely unless and until whole energy is removed. So this is called as a vibration. Now tell me, have you understand what is the mechanics or what is the mathematics behind the vibration of a spin system? If you have understand, okay. So whatever I have explained, I have written over here, so you will get this PPT. Okay. So now let us understand next simple pendulum. Okay. Now simple pendulum. Now how does the simple pendulum vibrate? So first of all, message me, guys. Have you understand this? Have you understand the vibration of a spin system? Anybody? Message me. Have you understand or not what I am explaining? Okay. Now, yes. Now simple pendulum. Now example number 2. Because this simple pendulum, again the mathematics or the mechanics behind the simple pendulum will be different. So let us understand the mechanics behind the simple pendulum. So basically, what is simple pendulum? First of all, let us say that this is the point O, a point O suspension. This is a string having a length L, and this is a ball of mass m. Okay, now initially this is nothing but an equilibrium position. Okay, now if this is the equilibrium position, what will I try to do? First of all, what we'll do, you have to apply some external force. Applying some external force means what? You have to give some displacement. Let us say I am applying the external force like this in this direction. Okay, so my displacement will be like this in the direction of the applied force. So let us say mass m. So mass m has moved in this direction. Okay, so let us say this angle is theta. So theta is nothing but an angular displacement. So let us say this is nothing but a theta, this is nothing but a theta dot, and this is nothing but a theta double dot. Now I have come into the angular system or the displacement system. Okay, now let us say this is a position number 1, position number 2. As I said that how it is happening, I will explain later on. So now from this position number 2, this mass will come to this position number 3. So from this again it will come this. So this is called the position number 3. So let us see. Okay, let us say this is again a theta. Now we know that this is nothing but the equilibrium position, and this 2 is nothing but the extreme position, this 3 is nothing but the extreme position. Now guys, I have already explained you that at extreme position your potential energy will be maximum, and at mean position your kinetic energy will be maximum. Again your potential energy will be maximum. Now very important point is that in the last example, the potential energy which was stored is called as the internal potential energy, or it is called the elastic strain energy, and strain energy is calculated by 1 of kx square. Okay, but in this case the potential energy is not a strain energy, but it is due to the, with respect to the datum position. Datum position means what? This is a datum position. Okay, and means what? If you take an example of a dam, you know that the water inside the dam is stored at a specific height. So there is a potential energy which is stored inside that dam. Okay, and that potential energy is nothing but calculated by mgh. So potential energy with respect to the datum position, that is h at height m and g, is nothing but mgh. So so you have to first of all understand whether the energy is a potential energy with respect to the datum position or it is a strain energy. So that you have to understand. Is it clear? Okay, so I have, now this is a diagram. Okay, so now you have understood what I have done. So now this is a diagram which I have drawn here. So first of all, let us understand the mechanism. So this is nothing but a datum position. Datum position means what? At some point where your mass was at the equilibrium position. Okay, your mass was at the equilibrium position. So let us say this position is position number 1. This is nothing but a 2, and this is nothing but a 3. Okay, so what have you done? You have applied a force. You have given an angular displacement theta. Okay, so now let us say if this is the L, if this is the L, this is also L, right? So basically you know that if this is the theta, okay, if I draw a vertical line here, so this will be also theta. Okay, so if this is a L, this is a theta, this vertical distance will be what? L cos theta. This vertical distance will be L cos theta, and this horizontal distance will be L sin theta. Now this is a basic mechanics because this is a right angle triangle, right? So, and these are nothing but alternate triangles, theta and theta. So this is theta, L cos theta, this is L sin theta. Okay, this is the datum position, and this is the equilibrium position 1. Okay, from 1 I went to 2, and from 1 and went to 3. Okay, have you understand the mechanics behind this? Okay, now this is L cos theta. Now this is nothing but a height h. Height h means what? Initially it was at a position 1. Okay, what you did? Okay, you applied a small angular displacement theta to this mass m. This is mass m. Okay, and because of the angular displacement, what happened? This mass m went to the 2 position. So at 2 position, the distance between this mass at 1 position and 2 position is nothing but h. And tell me what will be this h? This total distance from O point up to this position 1 is what? L. So this h will be what? L minus L cos theta. H will be L minus L cos theta, and that is equal to L into 1 minus cos theta. Okay, so now how will you calculate potential energy? Potential energy is equal to mg into h. What is m? The mass. What is g? 9.8
gravitational acceleration.
force. And what is h? H is nothing but the height from this datum position. So now you know that this 2 is nothing but the extreme position. This 2 is nothing but the extreme position. So at extreme position, okay, your potential energy is maximum, and how will you calculate? mgh. This 3 is nothing but the extreme position. where potential energy is nothing but the mgh, and where h is nothing but the L into 1 minus cos theta, how you calculate. Okay, and at this mean position, your kinetic energy is equal to maximum. And you know how you calculate the kinetic energy is nothing but a 1 m into v square. What is v? Velocity. Now, as I said that x is a displacement, so x dot is the velocity. So this formula becomes 1 half m into x dot square. So kinetic energy is calculated from 1 half mx dot square. Potential energy is calculated from mgh, and strain energy is called calculated as 1 half kx square. So three formulas I have explained you how to calculate. Is it clear? Okay. Now this is the mechanics what I have explained you. Now let us understand exactly why this system is vibrating. Why this system is vibrating? So for that we have to understand the torque. Now what is this torque? First of all, let us say I will draw a diagram aside to understand what is the torque acting at this position. So what I said, position 3, position 1 and position 2. Okay. So first of all, let me complete this. So this is L cos theta. This is theta. This is L sin theta again. Okay. This is H. Now H is equal to L into 1 minus cos theta. This we know that. So 3 and 2 are nothing but extreme positions. Okay. So that we have seen. Now basically you know how this theta is acting. Let us say this is a point O. Okay. I am drawing like this. This is a point O. Okay. Now let us say this is a mass. Okay. So I have gone to this position. I am drawing it separate to help you to understand this torque. Okay. Now what is the torque? Now we know that what is the weight? How is the mass acting? Mass is acting in the downward direction. So what is that mass? Let us say this mass is mg. Okay. This mass is mg. So if this mass is mg, okay. Let us say this distance is L. This distance is theta. This will be also L. Okay. Now we know that this mg can be divided into two components. What are the two components? Mg sin theta, and second component will be mg cos theta. Where I can write this. This will be mg cos theta, na? Mg cos theta. Okay. So mg sin theta and mg cos theta. Now tell me, what was the direction of theta? Direction of theta was like this, theta. Okay. Now you know what is the inertia torque. I have already explained the compound below. Inertia torque is nothing but I into theta. Okay. So inertia torque I into theta double dot. This always act in the direction of the theta, because theta and theta dot and theta double dot, they are in which direction? They are in the anti-clockwise direction. So I theta double dot is nothing but the inertia torque, which will also act in the anti-clockwise direction. Now tell me, there is another torque which is called as a torque due to the gravitational force, or it is also called as the external torque, or it is also called as a restoring torque. It is also called as a restoring torque. This restoring torque will try to bring the system to its equilibrium position. Now tell me, what is that restoring torque? Compound pendulum च्या युनिट मध्ये सांगितलं होतं. How will you calculate this restoring torque? mg
sin theta.
mg sin theta multiply by what is the
L.
distance? L. Yes.
L.
So mg, now you know that sin theta is very small. So sin theta is equal to theta. So I am considering sin theta is equal to theta. So this will become mg theta into L. So mg theta into L is nothing but a restoring torque, which is also called as a torque due to the gravitational force. So this mg theta L, or you can directly call it as a mg sin theta L. You can also call it as a mg sin theta L or mg theta L. So this is the restoring torque which will try to bring the system to its original distance. Okay. So means what? This torque will act here. So this is nothing but the T. Okay. So this is nothing but the T. Can you see where I am showing the T? Okay. So this T is nothing but a torque. This T is nothing but a torque which is acting at this position T. So guys, exactly what happens? See, when this mass M is moved from position 1 to position 2, at position 2, your potential energy becomes maximum and this torque starts acting at this position 2. And this torque is called as a mg sin theta into L. And this torque is also called as a torque due to the gravitational force. And because of this torque, see how this torque is acting? This torque is acting counter in clockwise direction. Now, because of this torque, that is acting in a clockwise direction. From this position 2, here again this mass will come to the position number 1. And at position number 1, your kinetic energy will become maximum again. And because your kinetic energy will become maximum, this mass will not stop at position 1. It will again move to the position 3. And again at position number, we have potential energy will be maximum. And again this torque, which is this torque, mg sin theta into L, it will start acting counterclockwise. So this T is called as a T counter. Okay. So this T counter clock will start again acting, and again it will bring this mass 3 from the position 1. Again at position 1, the kinetic energy will become maximum, and again it will come to the position 2. And in this way, this pendulum keeps on oscillating from 1 to 2, 2 to 1, and 1 to 3 because of this torque called as a mg sin theta into L. And this is called as a vibration. Now guys, tell me, have you understand the mechanics behind this? Okay. And this will happen, and this will go on happening. Okay. So this will go on happening. This will go on. So this is, you can say, this is the figure what I have explained. So this will go on happening until all the energy is dissipated. Okay. Is it clear? Okay. So this is, so at position 1, velocity and kinetic energy of Bob is equal to 0 at position 1. So I have mentioned potential energy with respect to datum position 2 is equal to mgh. Okay. So potential energy with respect to the datum position 2 is always mgh. H is equal to L into L minus L cos theta. Potential energy equal to mgl 1 minus cos theta. And torque due to the induced gravitational force mg about 0.0 is T is equal to mgl sin theta. So this is the mechanics what I have explained. Now tell me, have you understand or not? If you have a doubts, I will explain again. Otherwise, I will move forward. So have you understand both the examples? How does the system actually oscillates, and how, what is the mechanics behind the vibration in both the cases? Yes, anybody who still haven't understand or exactly what exactly happens, what is the mechanic behind this? Okay, how this torque acts, how you calculate this torque, what is this T counter torque and all? Yes, have you understand this?
Yes, sir.
Okay. Now there's one more point which I would like to explain. Now let us say that theoretically, what we consider theoretically, this cycle is indefinite. The cycle is indefinite. Theoretically, the cycle is indefinite. Indefinite means what? This from position 1 to 2, 2 to 3 means what? This mass will keep on oscillating from 2 to 1, then 1 to 2, then 2 to 3, then 3 to 2, then 2 to 1. So this process, see, this process that is 2-1 to 2-1 will keep on indefinitely, theoretically. म्हणजेच काय? Vibrations से कायम राहणार आहे, theoretically. But practically असं होत नाही. Practically what happens? Practically there is some resistance offered by the surrounding medium. Means what? There is a resistance offered by surrounding medium. Resistance offered by surrounding medium. And what is the surrounding medium, guys? Tell me, what is the surrounding medium? Surrounding medium is nothing but the air. So air resistance will always act, and this air resistance will, because of this air resistance, the energy which has entered inside the system, it will get dissipated, and after some point of time, this mass will get settled at this position number 2. म्हणून आपण काय करतो, जे वॉल क्लॉक असतं ना, ते एका काचेमध्ये टाकतो आपण त्या ग्लासच्या आतमध्ये टाकतो. म्हणजे त्या ग्लासच्या आतमध्ये जोपर्यंत आहे तोपर्यंत एअर रेजिस्टन्स तिथे असणार आहे का? देयर विल बी नो एअर रेजिस्टन्स, अँड दॅट इज वाय वन्स यू डिस्टर्ब द सिस्टम, एकदा का तुम्ही तिला डिस्टर्ब केलं म्हणजे काय, you have given a small angular displacement theta in anti-clockwise or clockwise direction, whichever direction you give doesn't matter, and you place inside the, म्हणजे व्हॅक्यूमच्या आतमध्ये तुम्ही प्लेस केलं, त्याच्यामध्ये झिरो एअर असणार आहे ना, निगेटिव्ह एअर असणार आहे. निगेटिव्ह एअर म्हणजे काय, व्हॅक्यूम असणार आहे. म्हणजे तुम्ही ही सिस्टीम जर व्हॅक्यूम मध्ये सस्पेंड केलं किंवा एका ग्लास मध्ये सस्पेंड केलं, ती प्रॅक्टिकली इनडिफायनेटली ऑसिलेट होत राहते. सो व्हायब्रेशन्स आर इनडिफायनेट इन दोज केस. बट इफ यू break that glass, or if you place that system in the air medium, there will be the resistance of the air practically, and it will come to its equilibrium position. So that is why that wall clock pendulum was placed inside that glass, because of the air resistance, that system will come to its static position. Now tell me, have you understand it or not? So I can move forward. Have you understand? Have you understand the concept of a vibration? This is very, very important. You have to understand the concept of vibration. And I have taken the two examples of a simple pendulum and a spring mass system, because we will consider only these two cases in your exam, in your analysis. Okay. Now, in next lecture, we are going to understand how to calculate the natural frequency of a spring mass system and how to calculate the natural frequency of a